Hey, 20-1s. Here is a small video for you about looking at our trigonometric ratios from 0 to 360. When we're talking about a trig ratio, even better off, we should call them the primary ones. We're looking at sine, cosine, and tangent. And again, we've seen these in grade 9 and grade 10. But what we want to do now that we're in grade 11, what we talked about in the last lesson, was drawing these in standard position, which means we're drawing these on our Cartesian plane. And so what we need to figure out now is how do we work with sine, cosine, and tangent and our favorite mnemonic device from grade 10, SOHCAHTOA, how do they work in standard position? Well, actually, they're really easy to use in standard position. So there's nothing too crazy in what we're about to do in the first part here. So I'm going to draw something in standard position. So as soon as I see that word standard position, I'm going to draw my Cartesian plane. Then all we're going to do is this. When we draw our triangles, now we're always going to think of them centered at the origin. And if you watch my history lesson of trigonometry, you would know why. Okay. And what we're going to do is we're going to think of the hypotenuse is always right there. And our right triangle is what we're only going to work with here, will always be drawn to the x-axis. And so when we label these sides, we label them x, y, and we could call this a hypotenuse, but we're going to call that the radius going forward. Again, if you watch my history lesson, what happened here is that this is actually the sun, and we are following it as it goes around us. And so you can see that it makes a circle. So the term radius makes a little bit more sense than hypotenuse, but if you want to think of it as the hypotenuse, that's just as fine too. No problemo. Okay, so what we're going to do here is we always draw our right triangle to the x-axis. So look at how we can draw triangles now. We've got that one there. We've got another one that could be drawn here. And there's another right triangle that could be drawn there. Almost looks like a bow tie. So what we're going to do is we're always to the x-axis. And then we're just going to have to find our side lengths. Just need to be really careful when we start looking in quadrants outside of quadrant 1. Notice over here, our x would be negative. And in quadrant 3, our y would be negative. And over in quadrant 4, our y here would be negative. Our radius is always positive. Okay, so the radius or the hypotenuse is always positive, but the x and the y values are switching signs depending where we are. So let's take a look just in quadrant 1 here for a second. So if I said, here's angle theta, theta is always measured from the x-axis, sine theta would be opposite over a hypotenuse, but now we're going to define it as y over r instead of opposite over hypotenuse. It's the same thing, just defined slightly different. Okay, cosine theta, we're used to saying from grade 10 adjacent over hypotenuse, but now we're going to say x over r. And tangent theta, we're used to saying opposite over adjacent, but now I want to think of that as y over x. So these are slightly not new, maybe updated definitions for our trigonometric ratios. Now, the other thing we want to notice is as we go around the Cartesian plane here, so again, we follow the path of the sun. So this is quadrant 1. All of these, sine, cosine, and tangent, would all be positive. So they're all positive in quadrant 1. But if we go to quadrant 2, all of a sudden our x value is negative. Well, what that's going to do here is it's going to make cosine and tangent negative, but sine would say positive. So I'm going to say that sine is positive. In quadrant 3, the only thing that would be positive here would be tangent because y and x are both negative, and a negative divided by a negative is a positive. So tangent is positive in quadrant 3. And if I follow the same reasoning in quadrant 4, the y value is negative. So the only thing that would remain positive is cosine. Why am I talking about what ratios are positive and negative? Well, this is going to help us determine where to draw our triangle. And what we just did, or what I just showed you, is known as the Cass law or the rule. What it tells us is basically where to draw our triangles. Okay, it tells us what ratios are positive in what quadrant, in which quadrant. So I'll show you what I mean. Where does the word cast come from? Well, look at, switch to pretty pink. C-A-S-T. So the Cass law tells me in quadrant 4, cosine is positive. In quadrant 1, all ratios are positive. In quadrant 2, sine ratios are positive. And in quadrant 3, tangent ratios are positive. That's all it tells us. You just need to remember that we're starting in quadrant 4, not in quadrant 1. Let me show you how this works. It's really easy. So given the point, -3, -4 lies on the terminal arm of an angle theta in center position, determine the exact values. Okay, so I hear that word or I read that word, standard position, Cartesian plane. There's x, there's y. It says we have a point on a terminal arm. So that means we've started at 0 degrees and there's our terminal arm and it's rotated to wherever we're ending up. -3, -4 is down here, quadrant 3. I draw my right triangle. There it is. Now I'm going to label my side lengths. -3, -4. That's a right angle. Okay, and it says determine the exact value, so no decimals, of the primary trig ratios. Okay, so what we're going to do here is we're going to say what is the value of sine theta, cos theta, and tangent theta. Well, I know we're in quadrant 3, but I'm going to write my Cass law, C-A-S-T. So what does this tell me? It immediately tells me the signs of the 3 ratios we're about to find. Tangent is the only one that will be positive. The other 2 will be negative. That's what that's telling you. Okay, so that's the Cass law. Now, sine is y over r, opposite over hypotenuse. Well, we got to find the hypotenuse or the radius here. It's a trigonometric, it's a Pythagorean triple, so that's going to be 5. But you would just use a squared plus b squared equals c squared to find that if you had to. And so now we can really quickly say sine is -4/5. So when you see a negative, don't freak out. It's telling you the direction or where we're drawing our triangle. Cosine is -3/5. And tangent, opposite over adjacent, well, it's -4 over -3, and 2 negatives make a positive. There you go. So that's how you find the exact value of something drawn in standard position. That's not bad, is it? And the Cass law tells you what ratios are positive and negative. Now, the one thing I'm going to note, because we're about to do it, is we rotated from our initial arm here. So this whole length here is theta, okay? That's how far this has traversed, okay? So now our job is to find theta, which is the trickiest and most important part of this lesson. So solving for angles. Given cosine is equal to 0.3, determine theta for 0 to 360. So that 0 to 360 tells me I'm looking on this entire Cartesian plane. However, it tells me cosine is positive 0.3. Well, what does that help me? How does that help me, I should say, right? Not enough coffee yet. Well, cosine's positive, so where is cosine positive? Cosine is positive here and here. So we're actually going to have two answers. We're going to have this one here, where we've rotated to here. I'm going to call that theta 1. But cosine is also positive down in quadrant 4. So that means there's going to be another terminal arm right here. And that means we started at 0 degrees right here, and we went all this way around. That is what I'm going to label as theta 2. So we're going to have two answers here to this question. Okay, how do we solve? Well, let's find theta 1 first. What's theta 1 equal to? Well, we know we've got cos theta is equal to 0.3. Well, we want to solve for theta. So what we do is we take the cosine inverse of both sides. And remember, the inverse undoes these two cosines. So the cosine inverse undoes the cosine is what I should say. And now all we've got to do is put that in our calculator, make sure that we're in degree mode. Okay, if you're not in degree mode, you're going to be in for a bit of a problem when you go to find this. So just in case you don't remember how to find degree mode or how to switch modes, I'll show you here. Okay, so remember what you do is you hit your mode button and see right there I'm in radians because they're more important, but we only deal with that in 30-1. And now I'm in degree mode. Okay, so now cosine inverse 0.3, and there we go. And let's round this to the nearest degree. So let's say 73 degrees. So theta is equal to 73 degrees. I'm going to say this is theta 1, by the way. There we go. There's our first answer. Now, how do we find theta 2? Well, once we found theta 1, theta 2 is actually easy. So what we want to say here is, okay, look, how are we going to get all the way wrapped around here? What are we going to do? Well, this angle we just found here, 73 degrees, is the same as this going backwards 73 degrees. So this here is also 73 degrees. So how are we going to find theta 2? Well, to find theta 2, what we're going to say is this. If we did a full lap all the way around, we would end up at 360. So how do I find theta 2? Well, theta 2 then is 360 minus 73 degrees. And that sounds like what? 287 to me. Okay, so what we did was to find theta 2 was we used theta 1. Theta 1 has a very important name. This is called your reference angle. Your reference angle, we talked about in the last lesson, is the acute angle measured to the x-axis. So we always want to find that reference angle first. Okay, now we got lucky because in this first example I did, we had an angle in quadrant 1. That's always going to be your reference angle. I'm going to show you what to do now that we're not in quadrant 1 always. Let's look at last example. Given sine is equal to negative 0.5, determine theta 0 to 360. Okay, draw the Cartesian plane. Cast law that. This one tells us sine is negative. So I'm going to draw my triangles where sine is negative. Well, sine is positive in quadrants 1 and 2. So I know it's going to be negative in quadrants 3 and 4. And I could draw the triangle, but I'm just not going to. So there's one, there's the other. Okay, what I always want you to do is draw in theta. So theta, remember, starts at 0 degrees. So it comes all the way there. So that's theta 1. And we've got two answers here. Theta 2 is all the way around to there. That's theta 2. Okay, so let's find theta 1 first. So theta 1. And really here the order doesn't matter in which we find these, but I'm just going into kind of in quadrant sequence. Okay, theta 1. Well, here's what we know. What they gave us was sine theta equals negative 0.5. Now, this is really, really important. We need to find the reference angle first. But when we start putting ratios in our calculator that are negative, we're going to have a problem. So here's what we're going to do. Is our ratio negative? If it is, here's how we're going to deal with it. And this is really, really important. We're going to make it positive. We're going to do this. We're going to find the reference angle. I'm going to call it sine theta sub r, which means reference angle. I'm going to make this positive because your calculator doesn't know what you're doing. And so essentially what we're doing, friends, is we're pretending that this is in quadrant 1, and it's going to help us find this reference angle right there. So now I do the sine inverse of both sides. And again, I'll show you that just in case. Make sure you're in degree mode. Okay, so sine inverse 0.5, and it's 30 degrees. Beautiful. So we go back to here, and we just found our reference angle is 30 degrees. So now, what does that help us with? Well, what we just found was our reference angle. And our reference angle is the acute angle measured to the x-axis. So that's 30 degrees, and that's 30 degrees. There it is. So now let's come back and say, what's theta 1 then? Well, theta 1, well, look at, if we started here and traversed all the way to there, that's 180, isn't it? So how do we get the rest of the way? Well, I'm going to say theta 1 is 180 plus my reference angle. Hey, that's 210. There's theta 1. How do we get lovely theta 2? Well, again, I started at 0. We went all the way around to here. But if I went all the way further, that would be 360. So all I'm going to do is just back it up. I'm going to say theta 2 is 360 minus 30, which is 330. And there are your two answers. So when you're doing this, this is probably the most important part and the trickiest part of this lesson. If you have a negative ratio, what you need to do is make that positive and find your reference angle. Okay, I call it theta sub r. Some people call it RA. Some people call it alpha. I don't care what you call it, but just make sure you're finding your reference angle. That's this right here. Then we use our reference angle to find theta. Okay, that is so important. Huge deal in 20-1, huge deal in 30-1. Okay, there is finding theta.